let's take a look at the next couple of weeks. So I've broken this again into a 2-week module. So if you look here, we end everything on 2/18. So a couple days after that infamous holiday, the Valentine's Day that everybody loves. So what I want to do is talk about functions first before we start looking at them and doing any of them. I want to take a look at them and kind of work our way through that a little bit. So bear with me here. I usually don't like to read stuff to you, but I want to cover some of the highlights. So one of the things we're going to do is we're going to use what are called functions. And functions give us the ability to do things over and over and over again in an entire set of modules. So maybe we want to do a module that asks for user input. And we have a validations and we have all kinds of pieces in it. But we know that we're going to use that more than once. So we could write it all in our main body of code, but that gets kind of ugly. And what ideally we hopefully have is we end up with code that looks kind of like this. In other words, we have a set of functions and we know what they mean. And so our main program, even our main program, we eventually are going to move into a function. So then we can kind of do that abstraction. It makes it easier to write a program that says, all right, I'm going to have a function that does the mean. I'm going to have a function that does the mode. I'm going to have a function that does the median. And in here, we pass in a set of values into those. And so we're going to talk about how we pass values and things into functions. But I think it's kind of important to understand why we do those kinds of things. And so even tools like this Notepad++, when we have functions or other pieces, I can shortcut it a little bit, and we can make them, I'm going to do A, B, C, D, and it makes life a lot easier rather than hundreds and hundreds and hundreds of lines of code. So as we work through some of this, I want to think about that. Functions are one of the things that are kind of hard to grasp for a little bit for some people. But they really are kind of like math functions. And we've been using functions since day one. When we did a print statement really is a function. So we have to be a little careful when we name them. We don't name them something that's already a function. But functions are an integral part, I think, of what makes our programming more powerful. So I want to look at something like this. This function here, so here we have a function called simple print. And notice I started it by simply doing the define. So I'm defining a function. This data gets passed into this function. So something comes up from our main code and gets sent into this function. And then it prints that and a set of lines under it and then a return. So the return says, I'm going to send this back to my mainline code, wherever that happens to be. So I'm going to open up an idle environment just because it's easier to see that, I think. So is it going to be on which page? Of course, it's on the wrong page. Never fear. All right. And so I'm going to do a file new. So I can have a new batch file. So I want to create something. Now I have mine ridiculously sized here, so remember that. So I'm going to do something like this so that I can see what I'm looking at. So I'm going to do something very similar to that print. Now, define. So notice it turns orange, says, oh, that's something important. Now, this is just kind of a convention in that we start our functions with a capital letter. We don't have to. But what it lets me do is I can tell the difference between a function then and a variable, because I'm not going to start my variables with a capital letter. And I'm going to do that with camel casing just because I like it better. And I'm going to pass in my string. Now, couple of things when I'm writing these functions. This colon on the end becomes really, really, really important. Because what that does is when I then hit the enter key, it says, oh, you're inside of this function, and it creates this indented block of text. So now anything that is indented at that level inside this function is a block of this function. So I could say then print my string. I could say print so I could put 100 lines in there. I could do another print any number of things I could do. I have a string that gets passed into it. I can manipulate that string. But in this case, I just want to demonstrate how that functions. I tend to put all of my functions at the beginning of my program, usually in a block, so that I can see them easily. So it's like function, 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 function. I know what they are. So I might even label them as begin function block, so that I know what they are. And then so that just lets me keep track of where everything is at. So I go backwards, so I hit the backspace key, and now I'm at this outside indent again. And so maybe I say, well, let's see. I want to input, so I want my string to be equal to input of please enter your name. So now my string should have that value of whatever you type in. Now, what I did not do is I don't have any way to call this function yet. So right now, if I run this, well, here, let me save it and run it. Sample 35 or whatever we're at. Okay. Invalid syntax. I've done something weird when I typed. Oh, it's helpful if I put the all right. So it says, all right, please enter your name. Okay. And then it quits. It doesn't do anything else because we haven't got it yet to call that function. We've just put data into this value called myString. To actually call that value, we're going to do this. So I look up and I say, all right, so my function is actually called simple print, and then I'm going to pass in a value. And that value, I could actually put it in directly. I could put in, now, if I do this, is my string doing anything? No. But let's see what happens if I run this. Please enter your name. Hello, Peru. Oh. But notice it does grab Dalton and send it up to that print statement. So instead of doing that, let's change that to my value of my string. So now I run it. So in this case, when I typed it then, I was able to do that the same way. So what that shows me is I can run that function, and I can run that function multiple times if I needed to for some reason. So if I needed to print this function again, so somewhere else in our program, instead of writing this function, now granted this one isn't very long, but later on we're going to get some more content in there. So this will then be able to be reused. And so as we start getting more complicated, you'll see how that's really an advantage. Right now it seems kind of silly. Why are you doing that? Well, so if I just copy and paste this in, so I run this program. Notice it's ran it. I don't know how many times I copied and pasted it in there. So my program isn't very long. I could have done the same thing by having multiple copies of that in my code, but I don't necessarily need to. All right, so that's kind of one of the basic pieces of this function. So if my function doesn't take any value, so maybe instead of simple print doing anything about printing a value that gets passed into it, maybe it just is the introduction or something else. If I do that, and I don't take anything in and I don't output anything, we typically call that a void function. In other words, it does something, but it doesn't move data into that function and it doesn't pass data back out of that function. So just to kind of keep that in memory, well, we see those in other applications. So I love Excel, probably my favorite product from Microsoft. So if I have a document like this and I want to put in what the date and time is, I could do it by hand, right? But that doesn't update every time this file opens. So there are functions inside of Excel which work very similarly. So if I do now, and notice I do the open and close parenthesis because I'm not putting anything into it, that gives me today's date, and I can format it however I want to, but it's a function just like what we're using inside of Excel. And then there are functions, so if we do a sum function, we're putting pieces into that. So if I did a sum, well, that's also a function. I passed in the numbers 3 and 4. Well, that's what we're going to do with our second example. I'm going to delete all of this, and I'm going to put in some functions. And I'm going to do main code. So again, this is my examples I'm going to look at. So the example they use I think, is a really, really, really good example of, here we're going to add some numbers that we get passed up to it. So I'm going to create this function first. And my function, and add numbers seems workable. So add numbers. And again, you can use the same nomenclature the book uses, but once you set out and you're using one standard thing, do that throughout your entire code. And again, if you're working for somebody, you may say, oh, they want us to do the variables this way. So define function, add numbers, And in this case, I'm actually going to pass two numbers up. Num1, num2. Now, those aren't the most descriptive numbers in the world, but they'll suffice for what we're going to do. And so now I need to come up with a value. So total works just fine. And I'm going to add num1 plus num2 and get something called a total. Okay, so we created a variable. And that variable, here's what's kind of interesting about functions. That variable only exists, unless we explicitly declare it as a global variable, only exists inside of that function. So I have to pass it back out of this function, and I'll prove that to you. Return total. So it's going to take this value here and pass it back into my mainline code. It's going to do a couple of things, and I'll show you here. So if I want to create something, I can also do this. So let's do the my total like they've done just to show you. Equals, and we're going to call this function add numbers, and we're going to pass in, and I want to show you that they're different values, and I'll show you here. So I'm going to pass in number 1, comma number 2. And notice those don't match, right? Does that seem weird? Why would I not want to make them match? Well, I don't have to because it passes them in. So my total equals add numbers, number 1 and number 2. Now what I don't have is those numbers, so I could set them up here. Number 1 is equal to 37. Number 2 is equal to 54. Or whatever I happen to type. Clearly I can't type and talk at the same time. All right, and so now we've called that function. We passed the numbers in. We returned a value. So now I need to just print so that value that I got here. So let's see if this actually runs and I haven't done anything really silly with my typing. Oh, look, it does, 93. So it went, added those together, and printed that out. Now, this program isn't very useful at this point, is it? No, but it starts to set the theme of. So what if I did this then? So instead of that, I put an input. And then, because I like to copy and paste, input please input second num. So now we could get people to put in their own numbers, right? So I'm going to run this. Let's see what happens. First one is 10. Second one's 20. Oh, wait a minute. Why did it give me that instead of what it should be a 30? Can you guess, Draven? So anytime I do an input, remember it's always coming in as a string variable. So what I could do is I could put a second line in here below it, and I could say convert that to int, or I could just do this. And now, if I go all the way to the end of that statement, which I made it super big so it's hard to get to the end, now I've converted them to integers right in the same line. So now if I run that, please enter the first, second, and now it gives me the right number. And there's a lot of other things we could do with that, but this just gives you a quick idea of what kind of functions and what kind of things we can do with them to start with. Now, I can break this really easily. So as soon as I put in a letter instead of a number, because we don't have any error checking yet, we're going to run into that. So at some point, we're going to have to figure out how to do some error checking. So we're going to kind of get to a little bit of that, and we're going to introduce you to another piece that's really interesting, and that is the if and the then and the else and all those kind of fun things. So I want to put in a condition of some sort. So down here, I want to ask a question before I print, because I may want to print differently depending on what that value is. So I want to say if my total is greater than 30, and notice I use that colon again, I jump down to the next line. And so it's an if, and only if that happens will this print. So print, you exceeded my calculator's ability. So this then says, all right, so if it's above 30, it's going to print, oh, I can't do that because you're over 30, right? All right. But the problem with this is if I just do this print line here is still going to run, because it's going to go through this and go, oh, only if this condition is true is it going to execute this if statement here. But it's then going to exit out of there and print my total anyway. So I need to think about how else I could work that. So luckily, else, so I can put this then in the same block. And notice I indented 1 with the tab key. So now, at the end of this, I'm going to put a print. All right, so now, depending on what my values are, I'm going to get 2 different reactions. I'm either going to get, you exceeded my calculator's ability, or I'm going to get a number. So I'm going to run this. All right, input a first number, so let's do 15 and 16. You exceeded my calculator's ability. And then I wanted to show that it would print that last line. All right, well, let's do it again with, and now it says, oh, there's my number of 20. So those if-then statements, so now we're going to show you some other variations, but if we just have these 2 conditions, we can ask a lot of questions. Well, my friend Excel here can also do those kinds of things. So if I say equals if, one value if true, so we have a test, so if this is greater than 5, and then our else statement is the value if false. So same idea, I just want to point out we use it and can use it in other areas. So If I change that, values high, values low. So I can do the same techniques inside of a lot of different areas. So Python just makes it ability so that we can do some of these things really, really, really easily. So we can do functions, and where we can put a lot of our processing up here, things we're going to reuse. So that's why we would do those kinds of things that we're going to reuse. All right. So if I go look at and I need to pull out the video links in here because apparently all of them have now died, which is great. Makes life, or the link itself is dead too. Come on, pretend you like me. Yay, there it slowly goes. All right, so I will go in and edit the video pieces out, and so we'll look at something very similar. So, um, this is really taking what we've already done, what we just looked at, and we're going to look at how do we actually do some of it. So I'm going to start idle again, so I can have more copies of it floating around. And so that's my interactive mode, but I want that batch mode, so I'm going to go File, New, and I'm going to pass it over to half of my screen. All right. So first thing I'm going to do is put my name in the project always, just so I can remember where I'm at. M2, A1 dash BG. So I know what my name is. And I might even come up with something like functions. All right. So whatever comments, make sure that you are putting some comment tags in here so I know what step you are at when I start running through these, please. Most of the people that turned it in did a really good job of that. So I just want to reinforce that's a good habit just to get into so we can figure out where we're at. All right. So talks about functions again and how we pass values in and out. All right. So here, so this is a function. Print sends it to print. So here we have a couple of details and we printed those values. Okay. So you're going to see that we do these kinds of things over and over and over again. So anything we're going to repeat, we typically put into a function. So let's take a look at this. Functions have to be, so all of the code that's indented, so define, I'm just going to call it something just so it'll show you. It's indented. The book says 4 spaces. I prefer just to almost always use that with the tab key. That way I'm sure I'm at the right spot. So anything in this is a block. So anything inside of there until it goes back to this outside layer is one block of code that's all going to run in that function. So in here, I may have values that get passed in, and I can have multiple values. If I need to pass in 3 or 4 or 5 or more things, I can do that. I need to make sure that they match. So if I try to pass 6 variables in and I've got it set up for 5, we're going to end up with a little bit of an issue. So parameters, we want to make sure that they match. This return at the end, that return is the end of my function. And again, I can return something or multiple values, but I don't have to. So depending on what this is, I can take in 0 to any number of things, and I can output any 0 to any number of things. I just need to make sure that they match. All right. So that's that generic form. And then I call that function either by name. So maybe I just say OKJS. Well, that will call that function. Or I can set it equal to a variable to call it. In this case, I have to pass in values to it. So right now, this isn't a valid function, obviously, but they give us some more examples here. So here's a hi function where function says say hi, and it says hello there, and then goodbye. Okay. Define 3 to display an integer. So print things are very common in here. So I'm going to delete all of this for now, and I'm going to look at step 8. So 8 says we're going to define and call a function named shouting. Okay. The function should display a phrase in all caps with the exclamation mark concatenated at the end. Initialize a variable myPhrase and assign it a short phrase of your choice. Example, extra toppings, please. But what I output needs to be all capitals. Oh, okay. So let's take a look at this one and kind of set it up and see if we can come up with a way to do that. So we're going to have a function. So the first thing we're going to do is we're going to define shout it. And we know we're going to take in a phrase of some sort. So maybe I'll just call it phrase. So it's going to take something in. And then we want it to output or print that phrase. But we want it to do a couple of other things. We want to add, at the end of it, we want to add an exclamation mark. So we want to change it a little bit. And I need it all in capital letters. So do we have a function in Python to make everything capital? So I'm going to go to our Googleator, Python string capital. Oh, the performing the dot upper methods. Where's the dot lower methods? Okay, so let's see if we have a way to do that. So if you're like me, I tend to like examples. So I'm going to look at this first one here. And it's got all kinds of things in here. So S equals where one cannot speak. And so if I do that, S dot upper. So this is the first time we've come upon this kind of notation. So let's see if we can make it work. Dot upper, dot lower, dot count, dot find, dot replace, dot string method. All right. So what happens if I, instead of having it at the top line here, I said this. I said phrase equals dot upper. Does that look like it might do anything for us? I'm looking at it. Is that similar? Maybe we should call it something different. So maybe we call this one temp equals phrase dot upper. But we also want to add to it. So we want to do the concatenation plus that exclamation mark. And then instead of printing phrase, we would print temp. We just use that as a temporary variable. So let's see what happens. I got to call it first, right? So I need a phrase. So I'm just going to say P equals give me liberty or death. And then I have to call this function. So shout it P. So let's see what happens when I try to run this now. Let's see if we're anywhere close to what we want to do. Oh, I got to save it because I started a new one. Documents. Oh, holy cow. Did that work? Give me liberty or death. Now, obviously, I shortened that out a little bit. Well, that's kind of cool that I could do those kinds of things to text. So, did I need to assign it to a temporary, or could I have done it all inside the print statement? I really could have done all of that inside of the print statement, quite honestly. But what that showed though is I can use that dotted notation to get some other pieces in there. So if I look back at some other ones in there, so I could count how many a character, or I could count the entire length of it, or I could do the length of the string. So there's a lot of other places we could utilize that, but I just want to give you an example there for that. So define a function named shout it. Yep, we did. Function to display a phrase in all caps with an exclamation mark at the end. Initialize a variable my phrase and assign it to a short phrase of your choice. Oh, okay. So I didn't do it that way, so I need to change that to my phrase. And then here I need to say so that it passes the right piece in. So notice I'm passing in my phrase. Is that the same name as here? No. It passes in the value. It doesn't pass in that name. And so in fact, in a lot of cases, if I tried to print phrase, it would actually hiccup. Or if I tried to print temp, it's going to hiccup because it's going to say, oh, no, that's only available inside of, so. And that's actually good. It says temp is not defined. Well, that's actually really good because for security, I don't want my variables to be available anywhere. I only want them in their functions where they're being utilized. So it actually is a really good thing. Okay. So let's take a look at number 10 here real quick. So again, we had some more examples. So number 10 says, write the code to define and call a function using a variable as the argument. Define a function called scream this. Get user input for the string variable words to yell. Okay. Call scream this function with words to yell variable as the argument. Display output in all caps with an exclamation mark concatenated on the bottom. So this is going to be very similar to what we did here. So we're going to define a function. In this case, we're going to call it scream this. And we're going to take in a variable of some sort. So I can leave this the same if I wanted to, because inside of this function, it's not going to be needed except for that. So inside our function, we're going to, what are we going to do? We're going to print. Now, I could do that all in one line. I kind of like this weird way of setting it up. But I can do something a little different. Instead of having to use that temp variable that goes away, I can actually do this. Equals. And I'm just going to copy that because we know that piece works. So what I'm doing here is I'm modifying it on the right and then shoving it back into the word phrase. So makes it a little shorter. And I'm going to do my return. So that is my entire function. Well, now I need to call this function with something. So I'm going to get user input. So I'm going to, what do they call it? Words to yell. Going to be equal to input. Enter a phrase. All right. So then we have to call this function. And to call this function then, we're going to say print. Well, let me think how we want to do that. How do we want to do that? I think we can just call it. We don't even need to do that. Scream this. We output there. And then words to yell. We pass that in. And we're good. Because all we need to do for 10 is to get this to work. So let's see if that works. Oh, I did something wrong. Oh, I see what I did. While I was talking, that goes chunk. There we go. Sorry. All right. So it did the Liberty one. So enter a phrase. I am not an animal. Okay. And it added the exclamation mark. So we can do that piece pretty easily. So then number 11 says, write the code using the print function to insert a blank line above the previous code. Write the code using the print function to insert a blank line above the previous code. So you could just have a blank print statement to do that. Number 12, copy the code from the screen this function above and revise it. Add one line, edit one line. So the function will include a default argument, a string of your choice. So if I don't enter anything, it's still going to print something. All right. So what they're saying is we can actually load this so that not only does it have this phrase being input, but we could say, I want something in case that phrase doesn't get created, that we can do that. So if I come in here and I say Python default in function, see if that will. So here we can have default values. So here we have our function, first name, last name. But notice how we say equals mark or equals fifth. So we could do the same thing here. So enter a phrase. Okay, comes up here. And we could say that phrase is equal to DJ Khaled. Now, so when I run this, enter a phrase. And if I just say, I don't want anything, or it breaks, in this case, it took my blank input and actually did run it and then just entered that. So we'd have to come up with something a little more clever to make it even better. But if I don't run this, so maybe this doesn't get ran somehow. So now if I run it, oh, because I don't have it defined anywhere. if we didn't have a value in there, we could actually force it to throw out my default phrase, right? Okay. So we talked a lot about the if statements and the else statements. So if, and then we have a condition, and if it's true, that's in the first block. And then else, this is our if any of the other conditions are present, or you could call it our false condition. So our program, Python, can work with true-false decisions. Well, that makes sense. We're in a programming language that at its very default uses zeros and ones. So everything we do is based on a 0 or a 1 for its operation. So we need to break down our decisions into what we call, well, into two-way flags, essentially. So a true or a false, yes or no, and that way we can do those kinds of things. Now, Python does have the ability to add multiple conditions in here. So we'll show you guys how to do that here. So there's another version. Oops, I really need to put it up here. Okay. So condition A is true. Elif condition. If that is true, and then otherwise we can go in the end. So if we think about how we would grade a paper and assign a grade to it. So if my condition, so let's use the phrase grade. So if grade is greater than 0.9, all right. So if that's not true, but I don't want to come down here where I'm going to get an F, right? So there might be another condition here. So if grade greater than 0.8, and that's going to print B, and then we can have multiples of those. So I can come back LF grade greater than 0.7, print C. Otherwise, anything else that happens, print try again next semester. So it takes this value and it's going to check it, and based on that value, what we're going to have for an output. So I'm going to delete all that temporarily, and I'm going to say grade equals 0.95. And if I run this, then telemarketer's calling already. What did I do there? Oh, hang on. So see where I said there's usually the errors are above it. I didn't put a closing parenthesis on there while I was typing. And then I'm going to guess that one is another one. Oh, forgot to put a closing. Look at that. All right. So if it's 0.95, I have an A. But if I change that to 0.65, try again next semester. So notice what we're doing is we're going through those step by step by step, and we can do that. So if statements are really, really powerful. We're going to start using them to validate our inputs. We're going to use them to validate what's going on and create loops and decision trees and all different kinds of other things. All right, so for this week, so you should be able to complete this activity, 2.1. All right, so for this week, there is a video about ChatGPT you may want to look at, and we're going to probably talk more about it as we go through here. There's some interesting pieces there. These two have some content, so how we pass values. So 2.1, 2.2, and then there are quizzes for each one of those modules. And then we will actually, I think we'll probably look at this functions quiz kind of together, or I'll put a video up of pieces of it as we go through there. So functions are a little harder. So we're starting to create some harder to conceptualize pieces. So, but if we think about it in terms of abstraction, it makes more sense to be able to write down my function, my program is going to do A, it's going to do B, it's going to do C. So again, think about my example here. So this program literally does the mean, mode, median out of a group of numbers that you've put in it. So we've even abstracted it to the point where the main function is hiding. So the only thing you would typically see is I have this piece, which tells us where to begin, and all of our code is tucked into functions. I don't need to know how to do the mean. I just have to say, all right, I'm going to go grab the mean. And I need to know that I pass in a list of variables. And then we have we do the mode, which is a little harder to do. And the median. So the median, we have to figure out how many numbers we have. So we'll get to ones like that, but not quite yet. But I just want to show you that abstraction where it makes life a little easier. All right. I will create at least one more video this week to show you guys some other items. And so there's really only 2 assignments, a couple quizzes, and then a longer test. But don't take the test yet until I create that second video, because I may go into some pieces on that test for you. All right. I'm going to close that out and close my recording down.